Hello and welcome. If you enjoy slow, careful journeys through the science of the universe, Pandanes, the kind that ask not just how things work, but why they exist at all, consider liking this video and subscribing. It helps this quiet corner of the cosmos continue to grow. And before settling in, take a moment to share where you're listening from tonight. A darkened bedroom. A room where the curtains are already drawn, a chair somewhere late and still, or perhaps a train moving quietly through the dark. Wherever that place is, something is passing through you right now, not the air you're breathing, not any light that remains in the room. Something that has never, in the entire history of the universe, interacted with a single photon of light. Something with no colour, no charge, that cannot be slowed or stopped or captured by any instrument we have ever built. And there is more of it, by mass, than everything else that exists. Combined, every star you have ever seen on a clear night, every ocean, every mountain, every planet in every solar system of every galaxy that has ever been mapped by every telescope humans have ever pointed at the sky. All of that, all of visible, touchable, ordinary Materie, accounts for less than 5% of everything that exists. And right now, 27% of the universeness, the single largest ingredient in all of creation minus, is flowing through this room, through you, through the ceiling above and the ground below, without pausing, without touching a single atom of any of it. It is called dark matter. And tonight, very slowly, we're going to try to understand what it might be. What is it made of? Why does it refuse all contact with light? How did we prove that something exists when we cannot detect it directly? Why have decades of searching, in tunnels bored through mountains, in tanks of liquid xenon buried nearly a mile beneath South Dakota, returned only silence? Could it be that we are simply wrong about the nature of gravity itself? And if we are not wrong, if dark matter is real, and present and dominant is, what does it mean that the majority substance of the universe is something no human has ever once perceived? We will not rush any of these questions. There are 3 hours ahead of us, and the story earns every one of them. It begins in 1884 in a Baltimore lecture hall, where a Scottish mathematician did some careful arithmetic on the stars and arrived at a number that did not fit. It runs through a Swiss astronomer named Fritz Zwicky in 1933 and a woman named Vera Rubin measuring the spin of the Andromeda galaxy with extraordinary patience, and a collision of galaxy clusters 3.5 billion light-years away that settled the question munis. Almost. And it ends for now in a mineshaft in South Dakota, where the most sensitive dark matter detector ever constructed has been listening for the better part of 2 years, in extraordinary silence, and has found nothing at all. Let the room go quiet. The dark matter will move through you regardless of whether you follow every word. It always has. So there is nothing here that you need to do. No fact you must hold on to. No thread you have to keep from slipping out of your fingers as your eyes grow heavy. Tonight is not a test, and the universe is in no hurry. It is waited some 14 billion years to be understood, and it will not mind waiting a little longer while you drift. All I would ask is that you let the words arrive and depart like weather moving across a window. A few of them will stay with you. Most will simply pass through the way that other stranger thing is passing through you even now, quietly, without resistance, leaving you exactly as you were, and yet perhaps a little less alone in the dark. And the place to begin is not out in the depths of space at all. It is here, in this room, with the simplest question we can ask of anything that exists. And that question, when you set everything else gently aside, is almost humbling in its smallness. It is the question a small child asks when they take something unfamiliar into both hands and lift it. How heavy is this? How much of it is there? Not what colour it is, not what it is for, not even what it is called, but simply how much of it there is to hold. It is the very first thing we want to know about anything strange, and it turns out, in the end, to be very nearly the last thing this universe is willing to tell us honestly. So let us begin where every science of the heavens quietly begins, which is not with light at all, but with weight. You cannot set a star upon a kitchen scale. You cannot cup a galaxy in your two hands and feel it press down against your palms. And yet, for several centuries now, we have known a soft and rather beautiful trick for weighing the things we can never touch. The trick is this: you do not weigh them directly. You watch, patiently, how they move. Everything that has mass pulls upon everything else around it, and the heavier a thing is, the harder it pulls, and the harder it pulls, the faster its neighbours must travel in order to keep from falling inward. So if you can only measure how quickly the neighbours are moving, you can work slowly backward, step by careful step, to the weight of the unseen thing that holds them in their courses. We weigh the heavens, in other words, by watching them turn, not by their brightness, but by their motion. Hold that one idea loosely as you lie there, because the whole long story of tonight grows out of it. The speed of the parts reveals the weight of the whole. That is all. It is the same logic by which you might guess the heft of a stone tied to a string, simply by feeling how hard you must whirl it to keep it circling your hand. The faster it wants to fly, the heavier you know it to be. Astronomers over the centuries became exactly this kind of patient measurer. They learned to whirl no stones and to lift no worlds, but only to watch, and from the watching, to weigh. The first person to feel a faint chill of unease from this trick was not some modern astronomer with a computer, but a great physicist of the Victorian age. In 1884, in the city of Baltimore, Lord Kelvin stood and delivered a series of lectures on the motion of the stars. He chose to treat the whole of our own galaxy rather as though it were a vast cloud of gas, with each star a single restless molecule, drifting and jostling among its fellows, and he reasoned quite simply that the speed of all those stars must reflect the total weight of everything pulling upon them. So he did the arithmetic, there in front of his audience, and he arrived at a conclusion that should have been more startling than it seemed at the time. Many of the bodies whose gravity governs how the stars move, he suggested, may give off no light that we are able to see at all. He spoke in effect of dark bodies, of matter that announces itself only by its pull and stays entirely absent from the eye. It was, you understand, not yet a discovery. It was a suspicion, a man following his numbers to the edge of what was comfortable and noticing that the books did not quite balance. A little over 2 decades later, in 1906, the French mathematician Henri Poincaré read into this kind of reasoning and gave the idea something it had until then been lacking. He gave it a name. He wrote in his own language of matière obscure, which we would translate simply as dark matter, and he wondered aloud whether there might be a very great quantity of it threaded through the heavens, or whether there might be hardly any at all. Notice the gentleness of that. It was not a triumphant announcement. It was not a claim hammered down upon the table. It was a careful question, set quietly upon the page and left open, the way a thoughtful person leaves a door ajar rather than slamming it shut. And then, for a long while, very little happened. This is worth sitting with for a moment, because we tend to imagine that science marches forward in a clean and constant line, each discovery arriving precisely when the world is ready for it. It does not. Kelvin had his unease, and Poincaré had his name for it, and then the idea simply rested. The instruments of the age were not yet sharp enough to press the matter. The suspicion was real, but it was faint, and a faint suspicion can drift unattended for a very long time before anyone forces it to become a number. Nearly 5 decades would pass, in fact, between Kelvin standing in Baltimore and the moment someone finally pinned the universe down and demanded that it confess exactly how much was missing, that someone was a man almost perfectly built for the task. His name was Fritz Zwicky. He was Swiss-born, famously sharp-tongued, and not in the least bit troubled by the disapproval of his colleagues, which is precisely the temperament you need to say something the rest of your field is not yet prepared to hear. He worked in California at the California Institute of Technology, and in 1933 he turned this old weighing trick upon something far grander than a single star or even a single galaxy. He turned it upon an entire swarm of galaxies at once. The object of his attention was the Coma cluster. Picture, if you like, not one island of stars but a whole great city of them, hundreds upon hundreds of galaxies gathered together and held in a loose, slow congregation by nothing but their shared gravity. Each galaxy within that city is itself a wheeling collection of countless suns, and the whole assembly drifts and orbits within its own enormous bounds. Zwicky set out to measure how fast those individual galaxies were moving as they swarmed about one another inside the cluster, and then he applied a principle of physics that lets you connect the speed of objects in such a swarm to the total mass required to hold them together. For if they were moving too quickly and the cluster were too light, then gravity could never restrain them, and the whole magnificent city would simply unravel and fling itself apart into the dark. What he found, when the figures were before him, was not a small discrepancy. It was not the kind of gentle mismatch one might explain away with a shrug and a better measurement next year. The galaxies of the Coma cluster were racing, careering through the swarm at tremendous speeds, far faster than the visible material of the cluster could ever account for. By the plain logic we have been following all along, that the speed of the parts betrays the weight of the whole, the cluster had to be vastly, almost absurdly heavier than every glimmer of light within it could explain. Not a little heavier, not merely twice as heavy, which would already have been a scandal. By his reckoning, the cluster needed something on the order of 400 times more mass than the shining galaxies seemed to provide. Sit for just a moment with how strange a number that is. If you weighed a thing in your hand and found it 400 times heavier than everything you could actually see inside it, you would not quietly correct your scale. You would begin to suspect that the object was, in some deep and unsettling way, mostly made of something you had no eyes for at all. That was the conclusion Zwicky reached, gazing at that distant city of galaxies. The light he could measure was not the substance of the cluster. It was a thin frosting upon something far larger and entirely unseen, something that held the whole swarm together by its gravity alone, while giving back not a single photon to the telescope. He set this down in print, in a Swiss scientific journal called Helvetica Physica Acta, and when he reached for words to describe whatever vast and silent thing was supplying all that missing pull, he wrote, in German, dunkle Materie, dark matter. It is the phrase we still use, very nearly a century later, lying here in the dark ourselves, and it carries within it that same honest admission Zwicky was forced to make. We can feel its weight, we cannot find its light. The name is not a triumph of understanding. It is a beautifully precise confession of ignorance, a label we have hung upon a door we still cannot open. And here is the quiet thing about Zwicky's number, the thing that should have changed everything in that very year and somehow did not. The same logic he applied to that faraway cluster of galaxies is the logic that governs the swarm you yourself belong to. Above you tonight, beyond the ceiling and the roof and the thin shell of the sky, our own galaxy is turning, and it too is moving in ways that its visible stars alone cannot quite explain. The unease Kelvin felt in Baltimore, the question Poincaré left ajar, the staggering figures Zwicky drew out of the Coma cluster, none of it was ever truly about somewhere far away. It was always, in the end, about the very structure of the place you live, the great wheeling thing that carries this room and this bed and your slowing breath around its centre once every few 100 million years. The missing weight was never out there only, it was here as well. It simply took the world rather a long time to believe it, and the believing, when it finally began, did not arrive as a single thunderclap. It crept in. It came in small, almost reluctant pieces, each one set down by someone who did not quite grasp the weight of what they were holding. Consider what happened only 6 years after Zwicky published his figure. In 1939, an American astronomer named Horace Babcock turned his telescope not toward a distant swarm of galaxies, but toward the nearest great spiral to our own, the Andromeda Galaxy, that faint, patient smudge of light you can still find for yourself on a clear and moonless autumn night, if you know roughly where to look. Babcock set out to measure how quickly the outer parts of Andromeda were turning, and he found in those farthest regions that the galaxy seemed to carry something close to 50 times as much mass for every unit of light it gave back as he had any reason to expect. Not a small surplus, a vast one. The outskirts of that galaxy were heavy in a way its glow could not account for. Here, then, was the same unease as Zwicky's, arriving from a completely different direction, through a completely different kind of measurement. Not a cluster of galaxies this time, but a single one. Not the violent jostling of thousands of members, but the calm, regular turning of one great wheel of stars. And yet, Babcock, like Zwicky before him, did not announce a new substance. He did not write that the cosmos was mostly invisible. He suspected, perhaps, that light was being absorbed somewhere out there, or that the physics of a galaxy's edge was simply more tangled than anyone yet understood. The number sat there in his paper, quietly enormous, and the world walked past it once again. And so the decades passed. The 1940s gave way to the 50s, the 50s to the 60s. A war was fought and ended. Telescopes grew larger, photographic plates grew finer, and still that stubborn arithmetic minus, the weight that would not match the light minus, was treated as a small puzzle at the edge of astronomy, rather than a crack running straight through its foundations. It was easier, always, to doubt the measurement than to doubt the universe. Then, in 1968, a quiet and meticulous astronomer arrived at Lowell Observatory in Arizona, carrying a new kind of instrument. Her name was Vera Rubin. She had been born in Philadelphia in the summer of 1928, into a world that did not expect women to map the motions of galaxies, and she had spent years learning to work around that expectation rather than against it. Alongside an extraordinarily gifted instrument maker named Kent Ford, she had a spectrograph far more sensitive than anything Babcock had ever used. A device that could read the faint shift in a star's light and translate it into a speed, a precise figure for how fast that distant point was moving toward you or away from you. And she pointed the 2-meter telescope at the very same galaxy Babcock had studied. She pointed it at Andromeda. What Rubin and Ford did next was slow, careful, and almost unbearably patient. Over those years, from 1968 into 1970, they gathered 123 separate spectra from the glowing regions scattered across the face of Andromeda, tracing the galaxy's rotation outward, point by point, all the way to 110 arc minutes from its bright center far out into the dim and thinning edge where the stars grow sparse. Each measurement was a single answer to a single question. How fast is this part of the galaxy turning? And then, a little farther out, how fast is this part? And farther still. Now here is what they expected to find, because here is what every law they had been taught insisted must be true. You know it yourself, even if you have never named it, because you live inside its smaller version every single day. In our own solar system, the planets nearest the sun race around it quickly, and the ones far out move slowly, and the most distant of all merely crawl. Mercury hurries, the outer giants drift. The pull of gravity weakens with distance, and so the farther a thing orbits from the centre of mass, the more leisurely its circle becomes. This gentle falling away is what astronomers call a Keplerian decline, named for the man who first traced the true paths of the planets, and it is one of the most dependable patterns in all of physics. Rubin and Ford fully expected to watch Andromeda obey it, the inner stars whipping around fast, the outer ones easing off, the speeds tapering quietly downward as they pushed their measurements toward the rim. That decline never came. The stars and the glowing clouds of gas out at the edge of Andromeda, objects at distances of 10,000, 20,000, 40,000, 60,000 light-years from its centre minus, were not slowing down at all. They were moving at very nearly the same speed as the material lying far closer in. The line that should have curved gently downward toward the rim instead ran flat, stubbornly, impossibly flat, stretching out across the dark like a single held note that simply refuses to fade. In 1970, Rubin and Ford published this result, a paper on the rotation of the Andromeda Nebula drawn from their survey of its emission regions, and folded inside that flat line lay a conclusion that could not be reasoned away. For those outer stars to be moving so fast and yet not be flung off into the emptiness, something unseen had to be holding them, a great reservoir of mass reaching far beyond the glowing disk. Mass that gave off no light whatsoever, mass whose only signature was the grip it kept on everything that did shine. And the same is true, remember, of the galaxy turning above you tonight. Its bright wheel is held by a hand you cannot see. And this time, the number did not sit quietly in a journal. Rubin did not stop at one galaxy. Through the 1970s, she and her collaborators turned the same patient method on spiral after spiral, and in 1980 she published a study of the rotational properties of 21 such galaxies, and every one of them told the same impossible story. Flat curve after flat curve after flat curve. Not a quirk of Andromeda, not a flaw in one telescope on one mountain in Arizona. A property, it seemed, of spiral galaxies as a universal feature of these great turning wheels scattered across the whole of the cosmos. And when Rubin worked through what those flat curves demanded, the figure that emerged was as humbling as Zwicky's had been, and far harder to dismiss. Every spiral galaxy she measured had to contain at least 5 to 10 times more mass than all of its visible light could ever account for. 5 to 10 times. The glowing thing you can photograph, the bright disk of stars that we had always simply called the galaxy, turned out to be only the small, luminous core of something vastly larger and entirely dark. So follow the line that these measurements draw from one careful soul to the next. Kelvin's faint suspicion in Baltimore, Poincaré's borrowed phrase, Zwicky's 400-fold cluster, Babcock's 50-to-1 edge, and then Rubin's flat curves, repeating across galaxy after galaxy until denial was no longer an honest option. Each figure made the one before it look quaint, almost charmingly small, a person squinting at a shadow they could not yet name, and each one was pointing, without quite knowing it, toward the very same conclusion. The thing the visible universe has always been doing, turning, holding together, refusing to fly apart, cannot be explained by the visible universe alone. And so here is the truth that took the better part of a century to fully arrive, the truth meant to settle over you slowly as you lie there tonight. Nearly everything that holds the heavens together is something no one has ever once seen. And once that strange sentence has settled into you, a gentler question rises to take its place, and it is the question this slow stretch of the night is quietly built around. Not who found the missing mass, and not in which decade, but how. How can a thing that sheds no light, that is never glinted in any lens or warmed any detector, still reach out across empty space and announce itself? How can something you have never seen possess a weight that can be measured carefully to several decimal places? The answer, as it happens, is older and plainer than the riddle it solves. It rests on a single quiet idea, one you have felt in your own body more times than you could ever count, without once thinking of galaxies. Here is the idea, and let it arrive slowly. Gravity does not care whether a thing glows. It does not ask whether a mass is made of hydrogen burning in a star, or cold rock drifting in the dark, or something stranger still that no name has yet been settled on. Gravity responds only to the presence of mass, full stop, and so anything with mass, seen or unseen, pulls. This is the whole secret, the hinge the entire science turns upon. You cannot weigh the dark by looking at it, because there is nothing to look at, but you can weigh it by watching what it pulls, by measuring the speed of the things it is caught and is holding in its grip. Motion is the witness. Motion tells you about mass, that light has kept silent. To feel why, return for a moment from the cosmos to something close and familiar. Imagine a stone tied to the end of a string, and imagine yourself swinging it in a slow circle above your head. The faster that stone wants to fly outward, the harder you must pull on the string to keep it curving back. A gentle pull holds a slow stone. A racing stone demands a fierce one. Orbits are nothing more exotic than this. A planet circling the sun, a star circling the centre of its galaxy, missness. Each is a stone on an invisible string, and the string is gravity. and the strength of that string is set entirely by how much mass is pulling from within the circle. So if you can clock the speed of the thing going round, you have, in effect, measured the strength of the string. And the strength of the string tells you the mass. You have weighed something you may never have seen at all. Now carry that simple rule outward, gently, to the place where it begins to misbehave. In our own solar system, the rule holds beautifully and behaves itself. Nearly all the mass sits piled up in the sun at the centre, and so the planets nearest that great central weight feel the fiercest pull and race around quickly, while the distant outer worlds, far from the bulk of the mass, feel only a faint and patient tug and drift round slowly, taking lifetimes to complete a single circuit. Speed falls away with distance. The further out you go, the slower things move. This gentle slackening is exactly what the old arithmetic predicts, and it is named after the astronomer who first traced the shapes of the orbits, the Keplerian decline. It is not a guess, it is what the solar system does, night after night, with perfect obedience. And so, when the first careful surveys reached out to the edges of distant spiral galaxies, this is precisely what everyone expected to find. A bright, crowded centre full of stars, holding most of the mass, with the outermost stars and gas clouds, far from all that light, far from all that weight, slowing down, lagging, falling into the same gentle decline that every outer planet obeys. The expectation was not arrogant. It was simply the rule, applied honestly, by people who trusted that the same physics holds everywhere. But the galaxies refused. Out at the faint and tattered edges, where there is almost no visible matter left to see, where the stars thin to a scattering and the light all but gives out, the orbiting gas was not slowing at all. It was moving just as fast as the material far closer in. The string had not slackened. Something out there in the apparent emptiness was still pulling, and pulling hard. There are, in the end, only two honest ways to read that fact, and one of them quietly falls apart. Either the law of gravity itself breaks down at these enormous distances, minus and a great deal of careful work has gone into testing that possibility, without success minus, or the emptiness is not empty. Either the rule is wrong, or there is far more mass out there than any telescope can show you, mass arranged not as a bright disk, but as a vast, near-invisible reservoir reaching out well beyond the glow. The flat speed of those outer stars is not a small anomaly to be tidied away later. It is a direct measurement of a mass that emits no light. And when you do that arithmetic, galaxy after galaxy, the answer that comes back is sobering and consistent. A spiral galaxy must hold something like 5 to 10 times more mass than all of its shining stars and gas could ever account for. The light is the small part. The light was always the small part. So picture, if you like, what a galaxy actually is, once the unseen mass is admitted into the account. The luminous spiral you would recognize, the pinwheel of stars, the glowing arms, the bright dense core Ninus, is not the galaxy itself, but only its visible heart, a small bright kernel resting at the centre of something far larger and entirely dark. Around it, swallowing it, extends a great rounded cloud of invisible matter, a halo, roughly spherical, far wider than the bright disk and far heavier. Our own Milky Way sits cradled inside such a halo, and the best models give it a characteristic span of something like 70,000 light-years and a total mass in the rough neighbourhood of 1 trillion times the mass of our sunlight. the overwhelming majority of it dark. The stars we have always simply called the galaxy are the glint of foam on a wave whose true body lies beneath. We named the foam. We are only now learning to weigh the wave, and here the question opens outward, from one galaxy to the whole cosmos at once, because the same accounting can be done for everything there is. This is no longer a matter of squinting at the edges of distant spirals. In the early years of this century, a satellite called Planck spent years patiently mapping the faint residual warmth left over from the Big Bang itself, the oldest light in existence. And from the precise pattern in that ancient glow, it read off the full inventory of the universe, a kind of cosmic census, a weighing of all that is. The numbers it returned are among the most exactly measured quantities in all of science, known now to within roughly 1 part in 100. And they say this: everything made of ordinary matter, every star and planet, every cloud of gas, every grain of dust, every living body that is ever drawn breath, amounts to only about 5 parts in 100 of all there is. Dark matter accounts for something close to 27 parts in that same 100, and the remaining 68, the great unaccounted majority, is a separate puzzle altogether, a thing called dark energy, which is a story for another night. Sit a moment with the smaller of those numbers, because it is the one this night belongs to. If you set aside the dark energy and ask only about matter, only about the stuff that has substance and weight and clumps together under gravity, then the dark kind outweighs the ordinary kind by something close to 6 to 1. For every gram of you, of this room, of the earth and the sun, and every star in every catalogue ever compiled, there are roughly 6 grams of something else, something that has never been seen, holding the heavens in its quiet grip. The matter we have spent all of human history studying, building telescopes for, splitting into atoms for, naming and sorting and burning, is not the main body of creation. It is a faint minority report. It is the small, bright, talkative 5% that happens to glow. And lest this stay safely far away out among distant galaxies and ancient light, understand that it is not far away at all. It is here. It is in the room with you. The dark halo of the Milky Way does not stop politely at the edge of the bright skyness. It threads through the whole galaxy, through the space between the stars, through the solar system, through the orbit of the Earth, through the wall beside you and the air above you and the body lying still beneath the blanket. By the best current reckoning, in every cubic centimetre of the space around you tonight, nailers a volume no bigger than the tip of your finger, there drifts, very roughly, something in the region of 1/3 of a single proton's worth of this invisible mass. It is passing through you as you breathe. It has been passing through you your whole life. It will keep passing through you after you have fallen asleep, gently, soundlessly, leaving no mark at all. And here is the question that ought, by rights, to keep you wide awake. Though tonight, of course, it is meant to do the very opposite. If this substance leaves no mark, if it slips through your body and the wall and the whole sleeping house without so much as a whisper, then how could anyone ever have known it was there at all? You cannot see it. You cannot feel it. No instrument ever built has caught a single particle of it in the act of being caught. And yet we speak of it now with a strange settled confidence, as though we had once held a handful of it up to the light. How can that be? The answer is gravity. Not light, not warmth, not sound gravity, the one force this hidden matter cannot refuse to obey. It may turn its back on every colour and wavelength of light. It may drift through solid rock as though the rock were an open doorway. But it has mass, and mass bends the paths of everything near it, and that bending is a thing we can watch. Think of the wind. You have never once looked at the wind itself. No one has. But you have stood at the edge of a wide field and watched the long grass lean and shiver and run in silver waves, and from the leaning of the grass you knew precisely where the wind was, and which way it moved, and how hard it pressed. Dark matter is known to us in just that way. We do not see the thing. We see the grass bend. So consider, slowly, gently, the way things move when gravity holds them turning in a circle. In our own solar system, the planets closest to the Sun travel the fastest. Little Mercury hurries around its tight orbit at a furious pace, while far out in the cold and the dark, Neptune drifts around its enormous circle at the barest crawl. This is not an accident. It is not a whim of nature. It is a rule, and the rule is beautifully simple. How fast a thing must move to hold its orbit depends on how much mass is pulling upon it from within. Almost all the mass of the solar system is gathered into the Sun at its heart, so the further out you travel, the gentler the pull becomes, and the more slowly a planet may drift and still keep its place. Speed fades away with distance. Astronomers understood this deeply, and for centuries, and they expected the same graceful falling away to hold true everywhere in every spinning system, in every swarm of galaxies, across the whole reach of the sky. It was a Swiss-born astronomer named Fritz Zwicky who first noticed that the heavens were quietly refusing to comply. In the year 1933, working at the California Institute of Technology, Zwicky turned his attention not to a single galaxy, but to a great crowd of them, the Coma cluster, an enormous congregation of galaxies bound loosely together by nothing but their own mutual gravity, hanging far out in the deep of the sky. He set himself a simple task. He wanted to weigh it, and there were two roads by which he might arrive at its weight. He could gather up all the light the cluster poured out, count its galaxies, reckon their stars, and estimate the mass from the glow. Or he could watch how the galaxies moved, how swiftly they drifted and wheeled within the crowd, and work backward, using a principle of physics that binds the motion of a held-together system to the total mass doing the holding. Two roads, one number at the end of both. They ought to have met. They did not meet. They did not come anywhere close. For when Zwicky measured how fast the galaxies of the Coma cluster were racing, he found them moving far, far too quickly, so quickly that the mild gravity of all that visible starlight could never in 1,000 ages have kept them together. A cluster holding only the mass its light revealed should have flown to pieces long before, its galaxies scattered off into the emptiness like sparks flung from a turning wheel. And yet there it was, whole, gathered, held. To keep it bound at the speeds he had measured, Zwicky found the cluster required something on the order of 400 times more mass than all its light could account for. 400 times. Not a modest adjustment. Not a stray error at the ragged edge of a measurement. An entire hidden ocean of weight, dwarfing utterly the little that shone. He gave the missing thing a name, writing up his finding for a Swiss physics journal. In his own German, he called it dunkle Materie, dark matter. It was almost a confession, that phrase, a small flag planted in the middle of an unknown country. Something is here. We cannot see it. We do not know what it is made of. or where it hides, or why. For now, we shall simply call it dark, and for a long while afterward, few of his colleagues wanted to believe him. But leave that quarrel where it lies, it will keep for later in the night. What matters as you lie here in the quiet is the true shape of what Zwicky had blundered into. He had not found some private oddity of one far-off cluster, a curiosity to file away. He had caught the first clear outline of the very thing that is drifting through your darkened room this instant. Because the same stubborn arithmetic that held the Coma cluster together is holding your own galaxy together, right now, above you. The Milky Way, that immense slow wheel of stars beyond counting, in whose quiet outer lanes your sun is patiently turning, spins far too fast for the matter we can see. By the light of its own stars alone, it too should have come unwound an age ago, its farthest reaches peeling away into the black. It has not. It holds. And the reason it holds, the reason the sun keeps its steady station, the reason the earth keeps faith with its orbit, the reason there is a warm and breathing you to lie in the dark and turn any of this over, Simnis, is that the whole bright wheel of the galaxy rests cradled within a vast and invisible sphere of dark matter, a halo far wider and far heavier than every star it carries. Let that thought move through you as slowly as the thing itself. Somewhere overhead, past the ceiling and the roof, and the last thin reach of the atmosphere, the halo begins, and it does not end for a very long way. It has no wall, it has no shore, it has no surface you could ever put out a hand and rest against. It simply thins and goes softly on, and you are inside it. You have never, for a single moment of your whole life, been anywhere else. So it is not merely that dark matter is passing through you tonight, it is that dark matter is the reason there is a you for it to pass through at all. It is the unseen weight that first drew together, the gas that kindled into stars, the stars that forged, in their furnaces, the very atoms now resting quietly in your bones. It was the scaffolding upon which the whole visible cosmos was raised. And the scaffolding was never taken away. It is standing still. It is holding still, tonight, all around you and straight through you, as faithfully as it held the first galaxies into being. There is, if you let it settle over you, something deeply consoling in that. All your waking life you have leaned upon the things you can see, and quietly mistrusted the things you cannot. And yet the largest, the steadiest, the most patient and faithful presence in the whole of your existence is a thing you will never once see, nor touch, nor hear, a silent hand laid beneath the visible world, keeping the stars from scattering and the night sky from ever coming undone. It asks nothing of you. It has cradled you since long before you were born, and it will go on cradling, softly and without the slightest effort, long after the last light in this room has gone quietly out. And yet a presence you can never see leaves a small, stubborn question hanging in the dark, and it is the kind of question that patient minds have never been able to leave alone. For it is one thing to notice that galaxies turn too quickly at their edges, and that great clusters of them hold together with a grip far firmer than their light can explain. It is quite another thing to say, with any real confidence, what is doing the holding. A missing weight in a column of figures is not the same as a substance somewhere in the world. It might only be a substance. It might instead be a mistake, and for a long stretch of the last century, a careful and honest person could have looked at all of it, Zwicky's cluster, Rubin's flat curves, the whole quiet accusation of the arithmetic nice, and wondered whether the fault lay not in some enormous unseen material at all, but somewhere far closer to home, perhaps in the sums themselves. Or perhaps more unsettling still, in the very law of gravity that everyone had trusted to keep those sums honest in the first place. Sit with that second possibility for a moment, because it is gentler than it sounds, and stranger. We take Newton's gravity, and later Einstein's, and we assume without a second thought that the rule which drops an apple from a branch is the very same rule, unchanged, out at the ragged edge of a spiral galaxy 60,000 light years from its centre. That is an enormous assumption. We have tested gravity thoroughly here, in the solar system, across the span of a few light hours. We have not tested it nearly so well across the span of a galaxy. So a reasonable mind might ask, what if gravity is simply a little different out there, in the thin and lonely places, than it is here in the crowded warmth around a star? What if there is no missing matter, only a missing correction to our law? It is not a foolish idea. It never was. And if it were true, the whole invisible scaffolding we have been leaning on tonight would dissolve into a bookkeeping error, an accountant's slip written across the sky. The dark matter would not be a thing that is present. It would be a thing that was never there. So here is the difficulty, laid out plainly in the quiet. Two explanations, pointing at the very same measurements, telling two entirely opposite stories. In the one, the universe is full of some vast, silent material we cannot see. In the other, the universe is exactly as visible as it looks, and it is only our idea of gravity that has been quietly wrong all along. From a rotating galaxy alone, you cannot easily tell them apart. Both can be tuned to fit the spin. Both can be made to match the curve. For decades this was the honest, uncomfortable state of things, a genuine fork in the road, with no signpost, and clever people walking confidently down both paths. And that is precisely the kind of impasse that could have gone on, unresolved for a very long time, were it not for one particular gift the universe occasionally hands us. Now and then, out in the deep, it stages an experiment we could never hope to build ourselves. It takes objects of unimaginable size and sends them crashing together, and then it lets us watch the wreckage settle across 100 million years, and in the shape of that wreckage it answers, quietly, the question we could not answer on our own. The particular collision that broke the deadlock lies a very long way off, in the southern constellation of Carina, the keel of that old imagined ship among the stars. It carries the dry catalogue name astronomers first pinned on it, 1E0657-56, though almost everyone came to call it something plainer and more vivid. The Bullet Cluster. It sits some 3.7 billion light-years from where you are lying tonight, which is to say the light now arriving to describe it left on its journey before the earth beneath you had cooled into a stable world, before there was an ocean, before there was anything here that could be called alive. And what that ancient light shows is not one cluster of galaxies, but two great swarms, each holding many hundreds of galaxies, that fell toward one another across the void and did not stop. They struck. They passed through one another at a speed that is difficult to hold in the mind while half asleep, somewhere between roughly 3,900 and 4,500 kilometers in a single second. That is among the most violent collisions ever measured anywhere in the cosmos. And yet, because it is so far away and so slow to unfold, it looks from here utterly still, a frozen tableau, a car crash held motionless in amber, waiting patiently to be read. Now here is why that crash could settle an argument no telescope pointed at a peaceful galaxy ever could. A cluster of galaxies is made of three quite different things, and a collision, unlike a quiet rotation, forces those three things to behave in three different ways. And so it pulls them apart and lets us see each on its own. There are the galaxies themselves, the bright islands of stars, and there are so few of them, spread across so much emptiness, that in a collision they mostly sail straight past each other, like two swarms of gnats drifting through one another without a single insect touching. Then there is the ordinary gas minosive, and here is the thing worth pausing on minosive, because most of the ordinary matter in a cluster is not in the galaxies at all. It is in vast, thin clouds of hot gas that fill the space between them, gas so hot it glows in X-rays, and there is far more mass in that gas than in all the stars combined. When two clusters collide, the gas does not sail through cleanly. Gas meets gas. It drags, it piles up, it slows, it heats, and it lags behind, caught in the middle of the wreck like water thrown against water. And then, if there is a third thing, if there truly is a great unseen mass, it should behave differently again, according to what it is made of. And this is where the counterfactual becomes so beautifully sharp enough to cut cleanly between the two rival stories. Suppose, first, that the skeptics were right, that there is no dark matter, and that the extra gravity is only a flaw in our law. Then the gravity of each cluster must simply track the ordinary matter, because ordinary matter is all there is. And since most of the ordinary matter is in the hot gas, the centre of gravity, the place that bends starlight most strongly, the place that pulls hardest on everything nearby minus, must sit exactly where the gas has piled up in the middle of the crash. That is the prediction, unavoidable and clear. Where the mass shows itself, the gas must be. But suppose, instead, that dark matter is real, and that it is some strange material that feels gravity, but almost nothing else, that ignores the gas, ignores the light, ignores even itself, and simply keeps going. Then in a collision it would behave like the galaxies, not like the gas. It would pass straight through the wreck without slowing, and it would sail out ahead, leaving the ordinary hot gas stranded and glowing behind it. And so the gravity would come apart from the ordinary matter. The weight of the cluster would be found in one place, and the bulk of its visible substance in another, with a clear and measurable gap between them. Two predictions, two futures, and only one of them could be true. In the year 2006, a team led by the astronomer Douglas Clow measured exactly where the mass of the bullet cluster lay, using a method of quiet genius misers. They watched how the whole scene bent the light of still more distant galaxies drifting far behind it, letting the cluster's own gravity act as a lens and reading the mass directly from the warping of that light. Then they placed that map of gravity over the map of the hot X-ray gas, the map of the ordinary matter, and the two did not line up. They did not come close. The gas sat where it had piled up in the centre of the collision, exactly as gas must. But the gravity, the true weight of the thing Kainas, had sailed on past it, split into two clumps riding out ahead with the galaxies, precisely where a strange, straight-through unseen material ought to be. The mass and the visible matter had been pulled cleanly apart by the violence of the crash. They published it under a title that did not hedge, that did not apologize, that made a claim as bold as anything in modern science. A direct empirical proof of the existence of dark matter. And the separation they found was not a faint hint, not a suggestive lean in the data. It stood at a confidence astronomers call 8 sigma, a way of saying that the chance of the whole pattern being some accident of noise, some fluke of measurement, is so vanishingly small that you could run the experiment for the entire age of the universe and never expect to see it happen by luck alone. And notice, as you lie there, what that quietly does to everything we have said so far. Up to now, the unseen mass has been an inference, a thing demanded by sums, a weight we deduced because galaxies spun wrong and clusters held too tight. It was reasoning. It was strong reasoning, but it was reasoning all the same, and reasoning can be undone by a better idea. The bullet cluster is something harder than reasoning. It is a place, out there in Carina, where you can point and say, the gravity is here, and the matter you can see is there, and the space between them is real. It is no longer a correction to a law. It is no longer an accountant's slip. It is a substance, caught in the act, having been physically separated from everything we are able to see, which means the fork in the road has closed and only one path remains open, and it leads somewhere far stranger and far larger than a mere mistake in arithmetic ever could. And yet, stay with this a moment, softly. There is no need to hold it tightly. Even a place is not quite the same as a certainty. A single collision, however clean, is still a single event. It could be a fluke of geometry. It could be a trick of the particular angle from which we happen to catch it. 3.7 billion light years away, its light older than the ground beneath your house. Science is right to be stubborn here. One beautiful result is a promise, and not yet a proof, and the proper response to a promise is not applause, but another look, longer and sharper than the first. So the question that follows is the plainest one imaginable, the one you would ask yourself if you were the astronomer holding the photograph. Could we go back? Could we look again, with a finer eye, and see whether the shadow had kept its place? We could, and only very recently we did. In the years around 2024 and 2025, a young researcher named Sungjun Cha, a doctoral student at Yonsei University in Seoul, turned the James Webb Space Telescope back toward that same wreckage in Carina. Webb is the most sensitive infrared eye humanity has ever lifted above the atmosphere, and where the earlier surveys had counted their background galaxies in the dozens and the hundreds, Webb could resolve thousands of them, faint and far, and scattered behind the cluster like grains of light through frosted glass. Each of those distant galaxies is a tiny ruler. Each is bent, ever so slightly, by whatever mass lies between it and you, and by measuring thousands of those small bendings at once, Cha and the team could redraw the invisible landscape of the cluster with a precision the first astronomers could only have dreamed of. The shadow had not moved. That is the whole of it, and it is enough. The dark matter still sat with the galaxies, exactly where the earlier map had placed it 18 years before, and it had not been dragged along with the hot gas, and it had not smeared or softened or drifted in the way it would have if it felt any force but gravity. The finding, published in the Astrophysical Journal letters, did more than merely repeat the old result. It tightened the noose. For every collision like this one is also an experiment on the dark matter itself, a test of whether the stuff can feel its own presence, whether two clouds of it passing through each other would tug, or clump, or slow, and the sharper the picture, the smaller the room left for any such self-interaction. The substance passes through itself as cleanly as it passes through the gas, and through the stars, and through you. It is not shy, it is simply and profoundly apart. Now here is where the ground shifts beneath us, gently, and the thing we have been chasing grows suddenly and quietly enormous. For all its beauty, the bullet cluster is one place. It is one collision, one accident, one corner of one constellation, frozen at one moment of cosmic history. You could, if you were determined, imagine it as a curiosity, a strange local event that tells us something odd about a single battered pair of clusters and nothing more. But the missing substance does not confine itself to Carina. It has left its signature across the entire sky. And it wrote that signature not billions of years ago, but almost at the very beginning, in a moment so early that there were no galaxies yet to collide, no stars, no clusters, nothing but a smooth and blinding fog of light and matter, cooling slowly toward the dawn. To reach that signature, you must travel back not in space, but in time, to roughly 380,000 years after the beginning. Before that instant, the whole universe was too hot for atoms to hold together. It was a plasma, a dense and glowing soup, and light could not travel through it any more than sunlight can travel through the heart of a fire. Every ray was absorbed and scattered almost as soon as it was born. And then, as everything cooled, a threshold was crossed. Electrons settled onto nuclei. The fog cleared in a single instant that spanned the whole of creation at once, and the light that had been trapped was suddenly free to fly. That light is still flying. It is passing through your room tonight, through the walls, through the space between your resting hands. A faint and ancient warmth, stretched by the long expansion of the cosmos into a whisper of microwaves. We call it the cosmic microwave background, and it is the oldest thing you will ever, in any sense at all, perceive. Now listen to what that ancient light carries, because this is the part that matters, and it turns entirely on the one property we have been circling all night. In that early plasma, ordinary matter and light were locked together. The light pushed outward with its pressure, gravity pulled the matter inward, and the two forces fought, and the fighting set the whole fog ringing, like the inside of a struck bell, great slow waves of compression, and thinning rolling through the infant universe. Those waves were, quite literally, sound. And when the fog cleared, the pattern of that sound was frozen into the light, printed across the sky as faint patches, very slightly hotter and very slightly colder than their surroundings. Here is the crux, and here is where the dread grows quiet and cold. If the universe held only ordinary matter, only the stuff that feels light, then every one of those sound waves would have been shaped by the same tug of war between pressure and gravity, and the pattern would have followed one simple, predictable rhythm. But that is not the pattern we find. The waves are stronger where they ought to be weaker. The deeper tones are boosted, lifted, as though some vast unseen weight had been pulling the matter together, while ignoring the outward push of the light entirely, a hand on the scale that felt gravity but never felt radiation at all. There is only one substance we know that behaves in just that way. The same silent mass that bends the light in Carina was already there, 380,000 years into time, shaping the sound of the newborn cosmos. And this was not read from a single collision, nor from a single galaxy. A balloon-borne instrument called boom rang, first caught the leading note in the year 2000, drifting high over the ice of Antarctica. Then, between 2013 and 2015, the Planck satellite measured the whole chord of it, minus every tone, every overtone minus, from a cold and steady vantage far beyond the moon. And what Planck found, when it weighed those tones against one another, was not a rough agreement, but an exact one. The amount of unseen mass needed to make the sound of the early universe come out right is the very same amount needed to hold the galaxies together, the same amount caught red-handed in the bullet cluster, the same weight threading invisibly through the room where you are lying now. Two witnesses who never met, separated by billions of years and billions of light years, questioned in entirely different languages mustness, one in the bending of starlight, one in the ringing of primordial sound, mustness they have told the same story, down to the decimal. That is the layer that makes the collision feel small, and it changes the very shape of the question we are holding. We are no longer asking, timidly, whether the dark matter is real. That door has closed, quietly, behind us. We are standing now before a far larger and far stranger one, and it is the door that the rest of tonight will slowly begin to open. And so let us step through it, slowly, the way you might move into an unlit room, and simply wait for your eyes to soften, rather than reaching at once for the switch. There is no hurry. The question waiting for us on the far side is not a harder version of the one we have already answered tonight. It is a wholly different question, and it has a different flavour, and I want you to feel the change even as you drift, even if the words themselves begin to blur. We spent the early part of this night asking whether the unseen mass is truly there. The universe answered us in 3 separate voices that had no way of coordinating their stories, and all 3 agreed. Yes, it is there. But knowing that a thing exists tells you almost nothing about what the thing is. And that gap, that quiet and enormous gap between knowing that and knowing what, is perhaps the strangest feature of the entire subject. Consider, for a moment, how unusual our situation actually is. We have weighed this substance. We have weighed it, in fact, with a precision that would embarrass most of the things you can hold in your hands. That single number from the residual heat of the Big Bang, the one the satellite pinned down to the 3rd decimal place, is more tightly known than the mass of many ordinary objects around you right now. We can draw maps of where it pulls and where it thins. We can watch it bend the light of distant galaxies into arcs and rings. We can trace its scaffolding across billions of light years and show that without it the cosmos would never have grown its great filaments and walls. We can do all of that. And yet, if you were to ask the plainest possible question, the question a curious child would ask first, the question of what a single piece of it is actually made of, every honest scientist alive would have to tell you the same thing. We do not know. Not yet. We have never held one. We have never seen one. We are not even entirely certain what shape the answer will take. This is not a failure of effort. I want to be careful and gentle about that, because it would be easy to hear it as embarrassment, as though the whole of physics had simply been lazy. It is nothing of the kind. It is a genuine gap in what the human species knows, one of the largest and most patient gaps we have ever stared into, and the strangeness of it deepens the longer you sit with it. We have built a complete accounting of the universe, in which the largest single ingredient by weight is a thing we cannot name. 85% of all the matter there is, and we can describe its behavior beautifully while remaining completely ignorant of its nature. That is the door we have just walked through. Not the door marked "Is it real?", which is closed softly behind us, but the door marked "What on earth is it?". Now, before we can ask that question well, we have to clear away some rubble, because the word itself has misled almost everyone who has ever heard it. The word is dark. And dark is a terrible, misleading word, and I think it is worth a few slow minutes to take it apart, because once you truly let go of what it seems to mean, the rest of the night becomes far easier to rest inside. When you hear that something in the sky is dark, your mind does something very natural and completely wrong. It pictures shadow. It pictures a cold, unlit thing, a black cloud, a burnt-out star, a planet with no sun to catch, a lump of cold rock drifting somewhere too faint for our telescopes to pick out. And so for a long time, that is exactly what nearly everyone assumed the missing mass would turn out to be. Not something new, but something ordinary that had simply forgotten to shine. Faint dead stars. Cold reservoirs of gas. Dim bodies too small to ignite. The reasonable, sober guess was that a better telescope, a more patient survey, a longer exposure would one day reveal all this quiet, ordinary stuff hiding in the gaps, and the mystery would gently dissolve. It was a comfortable idea. It asked for nothing new. And it is wrong. Here is the heart of it, and I will say it as plainly as I can, so that you can carry it with you even into sleep. Dark matter is not dim. It is not faint. It is not a shadow waiting for a brighter lamp. It is transparent. Those are entirely different things, and the difference is the whole story. A dim object is one that gives off a little light, too little for us to catch across the distance. A transparent thing gives off no light at all, and stops none, and bends none aside. Light does not struggle to escape it. Light simply passes through it as though it were not there. The problem was never that dark matter is too far away, or too cold, or too small to see. The problem is that it does not touch light in any way whatsoever. It cannot emit light of any colour. It cannot absorb it. It cannot reflect it or scatter it or cast the faintest shadow. Across every wavelength we have ever learnt to measure, from the longest radio waves to the sharpest gamma rays, it is not dark in the sense of black. It is dark in the sense of invisible. And no telescope, however vast, however patient, however far into the future it is built, will ever see a thing that does not interact with light. You could park it directly in front of the brightest star in the galaxy, and it would leave no mark on the beam at all. And this is why the ordinary suspects, one by one, had to be let go. It is worth walking past them slowly, like reading names on a quiet memorial, because each one failed for a reason that teaches us something. The faint dead stars, the cold gas, the dim planet-sized bodies, all the things made of the same protons and neutrons that make up you, and the bed beneath you, and the air moving in and out of your chest. All of that was ruled out, and not by a shortage of imagination, but by a piece of evidence that is very hard to argue with. The ancient sound frozen into the early universe, the ringing we listened to together a little while ago, does not merely tell us how much unseen mass there is. It tells us what kind it cannot be. Ordinary matter, the baryonic kind, the kind that feels the push of light, behaves in that early sound in a particular way, and leaves a particular fingerprint. The fingerprint we actually find requires that most of the mass was already something else, something that did not feel that push, long before the first star ever kindled. So the missing substance is not ordinary matter that failed to shine. It is not made of the same ingredients as everything you have ever touched. Whatever it is, it sits outside the entire chemistry of the visible world. And it is not the ghostly little particle you may have heard whispered about either, the neutrino, that near weightless traveller streaming out of the sun by the trillion, passing through the earth and through your body every second, without so much as a nudge. For a while the neutrino seemed a tempting answer, because it too is nearly invisible, and it too drifts through matter as though matter were a rumour. But the neutrino is far too restless. It moves too fast, close to the speed of light, and something moving that fast cannot settle. It streams and it smooths. It would have flattened the early universe rather than let it clump, erasing the small lumps that later grew into galaxies. Dark matter did the opposite. Dark matter was slow and heavy in its behaviour and patient, and it let the lumps deepen. Not a swift ghost that smooths the cosmos then, but a slow, cold, gathering weight that shapes it. The neutrino, real as it is, cannot be the thing we are looking for. It fails in precisely the direction that tells us the true answer must be heavier, and calmer, and stranger still. So notice where clearing away the rubble has quietly left us. We began by imagining dark matter as something ordinary and hidden, and one by one the ordinary answers have been taken off the table. It is not a dim cloud, it is not a graveyard of cold stars, it is not a rain of small dark planets, it is not the familiar neutrino, it is not made of the atoms in the periodic table at all. Each of those was a door we hoped to walk through and find the mystery smaller on the other side, and each door, when we opened it, revealed only that the thing must be more genuinely new than we wanted it to be. And that is the peculiar shape of this pivot in our story tonight. Every ruled-out suspect does not shrink the mystery. It sharpens it. It narrows the search towards something the universe has never let us handle, a form of matter unlike any we are made of, threading silently through the room around you at this very moment, through the wall, through the pillow, through you, felt by nothing you own except the slow, faithful pull of its gravity. Which leaves us at last with the real and open question, the one the rest of the night will circle gently. If it is not any of the ordinary things, then what could it possibly be? There are answers on offer. There are candidates, imagined particles with quiet names, some of them dreamed up before anyone had proof the problem was even real. And there are people, right now, sitting in silence beneath a mile of rock, waiting in the dark for one of them to whisper. Consider, then, the first of those quiet names. Somewhere in the middle years of the 20th century, long before anyone could point to a single grain of the stuff, physicists began to sketch what it might be. They were not describing something they had found. They were describing something the equations seemed to require, and giving it a shape gentle enough to go looking for. The most patient of these guesses is the one they came to call the weakly interacting massive particle, a mouthful that softened, in the way of these things, into one small word that sounds almost like a shy creature, the WIMP. The idea was set down in a careful form by a handful of theorists in 1978, and its appeal was a certain elegance. Here would be a particle heavy enough to gather under gravity, perhaps 100 times, perhaps 1,000 times the mass of a single proton, and yet so reluctant to touch the ordinary forces that it could pass through the whole width of the earth, as though the earth were a bank of morning mist. And this is the first thing to hold gently in your mind about the WIMP and about all of its imagined cousins. It is not that these particles are rare, but that they are unsociable. Not that there are too few of them, but that they refuse almost entirely to speak to anything you are made from. A great multitude of them may be drifting through the palm of your open hand in the time it takes to breathe out, and your hand feels nothing at all, because feeling is a conversation held in the language of light and electricity, and these travellers do not know a single word of it. There is a second name, quieter still, imagined a year earlier, in 1977, by two physicists named Pesce and Quinmilis, though they were not at the time hunting for dark matter at all. They were trying to mend a small, stubborn wrinkle in the theory of the strong nuclear force, the force that binds the very hearts of atoms together, and out of that repair fell an unexpected gift. A particle so light it makes the WIMP look like a mountain. The axion, as it was later named, would weigh perhaps 10 trillionths of what a single electron weighs, not a heavy thing hiding in the dark, but a whisper of a thing, so faint that trillions upon trillions of them would be needed to add up to the weight the galaxies so plainly demand. And it carries one strange courtesy. In the presence of a strong enough magnetic field, an axion might very occasionally turn into a flicker of light, not because it is secretly made of light, but because the field can coax it, softly, across the border between the unseen and the seen. Which brings us at last back to those figures waiting in the dark. Beneath the Black Hills of South Dakota, in a town called Lead, there is a mine that once gave up gold and now gives up something stranger silence, carefully kept. Nearly a mile of solid rock lies above it, and that rock is not decoration, it is a filter. The surface of our world is forever showered by cosmic rays, a fine, ceaseless sleet of particles falling out of the sky, and to listen for something as faint as dark matter, you must first go down beneath all of that noise, down to where the mountain has strained the heavens quiet. There, in a great tank of liquid xenon, chilled and still, sits an experiment called Lux Zeppelin, and its whole purpose is simply to wait for one dark matter particle out of the uncountable throng passing through to blunder into a single atom of xenon and leave behind the faintest possible spark. From March of 2023 until April of 2025, it waited. 417 days of listening, in a stillness deeper than almost anywhere else on the planet. And in December of 2025, the people who tend it announced what they had heard through all that patient time. They had heard nothing. Now this is the pivot, the quiet turn in the story, and it is so easy to mistake for failure that we should be careful with it, and slow. It is not that the experiment did not work, but that it worked beautifully, and found the room empty, where the most likely guest had been expected to stand. Their instrument is now the most sensitive of its kind ever built, keen enough to rule out the heavier, more sociable versions of the WIMP, anything above roughly 5 times the mass of a proton, whispering at the delicate rate the theory had hoped for. And still, from all that careful listening, no answer came. There is a temptation to hear that as disappointment, and yet there is something almost tender in it. Each year the silence deepens, and the hiding places grow fewer, not because dark matter is retreating from us, but because we are slowly, patiently closing the doors it might have slipped behind. And here is the deeper turn, the one that quietly recontextualizes everything the night has offered so far. It may be that the WIMP, that elegant and patient guess, is simply not the answer, that the universe has gently declined the tidy solution we most wanted. and is holding out, instead, for something we have not yet learned how to imagine. For the truth, spoken plainly and without any alarm, is that we do not know how heavy a single grain of dark matter is, not roughly, not even nearly. When physicists gathered in 2025 to lay out everything they were searching for, the candidates they set upon the table spanned 90 orders of magnitude in mass. 90. That is the distance between a single drifting feather and a weight so vast the ordinary words for it simply run out. At one end sit the axions and their feather-light kin, so light they are almost nothing at all. And at the far end sit objects that are not particles in any ordinary sense, primordial black holes, born in the first second of the universe, before the first star had ever drawn a single breath of light, alongside other bodies so massive the word particle no longer fits around them. One estimate suggests that if the dark matter were made of such things, one of them might drift through our entire solar system only once in every 10 years, a lone dark traveller, crossing the whole vast neighbourhood of the sun and passing on into the night, unseen, unfelt, unrecorded. So the loophole and the dread turn out to be the same thing, wearing two faces. The loophole is that the answer is still out there, uncaught, which means it can yet surprise us. The dread is that it has been out there for the better part of a century of looking, and has surprised us chiefly by refusing to appear. And between those two minutes, between the fragile hope and the long, faithful silence beneath the rock, lies everything we do already know, which is more than you might expect, and stranger. For even without knowing what dark matter is, we have learned, in astonishing detail, what it does. And that, slowly, is where we turn now. Consider first how strange it is to know a thing thoroughly by its labour and not at all by its face. You can live a whole life beside a river and never once see the spring that feeds it, and still come to know every bend it turns, every field it floods, every stone it is quietly moved in the dark. Dark matter is something like that river. We have never held it, never lit it, never heard it ring against any instrument we own, and yet its work is written across the entire sky in a hand so steady, so patient, so unwavering, that we can measure it to a precision that would faintly embarrass most of the things we can actually see. That is the odd comfort waiting on the far side of this mystery. Not knowing in the least what it is, we have come to know, in astonishing detail, what it has always done. Begin with the very shape of that knowing, because the shape itself is part of the quiet unease. Almost every true sentence we can say about dark matter is a sentence that turns on the word not. It does not shine. It does not glow, not in the visible light your eyes were built for, not in the low hum of radio waves, not in the infrared warmth that leaks from a living body, not in the hard blue flash of an X-ray. It does not warm the space it fills. It does not slow when it meets a wall, a mountain, a whole spinning world. It does not scatter, does not smear against anything, does not stop. It does not, as far as our deepest and most patient experiments can tell, even collide with itself. Lay all these refusals down side by side, and something curious happens. The negatives do not cancel out into nothing. They stack. They gather, one atop another, into a portrait as sharp in its own way as any ever drawn in light. It is the portrait of something that keeps every promise a ghost might make, and then, quietly, does the one single thing that no ghost ever does. It pulls, it has weight, it reaches out across empty space and bends the paths of stars. And so you arrive at the deepening. The thing itself stays veiled, but its gravity is not shy at all. Its gravity is, in fact, the loudest and most honest voice in the whole cosmos mations. And once you learn to listen for it, you begin to hear it not only out there among distant galaxies, but backwards, all the way down through time to the very beginning of things. To feel the full reach of that pull, you have to travel back. Not a little way, but nearly the whole way, to a universe far younger than you can easily picture, a universe with no stars in it at all, no galaxies, no planets, nothing yet that could be called a place. For its first few 100,000 years, everything that would one day become ordinary matter was locked together with light in a single bright fog, a hot plasma glowing edge to edge, dense and blinding and restless. And that plasma could not sit still. Light pushes. Radiation presses outward against the matter it is bound to, and so this early ordinary matter did not simply gather under its own gravity night it sloshed, it rang, it rose and fell like a tide that could never quite come in. Wherever it tried to clump, the pressure of its own light shoved it back out again. But dark matter felt none of that. This is the heart of it, and it is worth letting the idea arrive slowly. Because dark matter does not touch light in any way minus, does not absorb it, does not emit it, does not feel its pressure at all, minus it was never caught in that bright sloshing fog. It did not have to wait. While ordinary matter was still trapped, still glowing, still pushed back from every well it tried to fall into, dark matter went quietly and went first. It sank into the faint, gentle lumps of its own gravity. It began unseen and unhurried to dig. It carved out valleys in the smoothness of the young universe, deep gravitational wells, waiting and empty, spread across the dark. And then, some 380,000 years after the beginning, the fog finally cleared. The universe cooled just enough for the plasma to settle into ordinary transparent gas, and in that moment the light let go of the matter it had held for so long and streamed free across space. The pressure that had kept ordinary matter sloshing simply vanished, and every atom that would ever become a star, a world, an ocean, a hand nines, all of it now rolled downhill, at last into the wells that dark matter had already dug and waiting all that while. So you can say something quite astonishing and mean it plainly. Galaxies exist because something you cannot see went ahead of the light, in the dark, and prepared the ground. The visible universe was built inside a scaffold it can never touch and has never seen. And here is the part that ought to make you sit very still if you were not already lying so quietly in the dark. We can hear the moment it happened. That early plasma, ringing and sloshing under the war between gravity and light, behaved like a struck bell Minaisness, and when the fog cleared, its final note was frozen into the faint afterglow that still fills all of space, the oldest light there is. When we read the pattern of that afterglow, we do not find a single pure tone. We find a chord, a series of notes, loud and soft in a very particular arrangement, and the relative height of those notes depends, quite delicately, on how much unseen matter was present to deepen the wells. Ordinary matter alone would sing one chord. A universe laced with dark matter sings another with the second note, and the notes after it, lifted and strengthened in exactly the way we observe. It was a balloon-born experiment, called boomerang, drifting high over the ice of Antarctica in the year 2000, that first caught the leading note clearly. And it was the Planck satellite, patiently mapping that ancient glow across the years 2013 to 2015, that measured the whole chord to exquisite accuracy. The music matches only if most of the matter in that young universe was dark. Not some of it, most of it. There is a second echo of that same frozen sound, and you can find it, if you know how to look, written into Where the Galaxies Sit Tonight. When the plasma finally let go of the light, the outermost ripple of each ringing wave was locked in place at a single fixed size, a fossil sound wave, stilled forever at a scale of about 147 megaparsecs, which is something near 479 million light-years across. And that frozen ripple left a faint, almost bashful preference in how far apart galaxies like to gather. Look at enough of them, across a wide enough patch of sky, and you find a whisper of a ring in their spacing, a slight tendency to cluster at that one particular distance, the ghost of a sound made before there were ears, or air, or anything to hear it. Astronomers found that whisper in the year 2005, hidden in the vast galaxy maps of the Sloan Digital Sky Survey and the 2-degree field redshift survey. And that whisper, too, only makes sense, only lands at the size we measure, if dark matter was already the dominant weight in the cosmos when the sound was made. Different instruments, different centuries of light, and they all point to the same silent partner. Now let all of that settle back down toward the room you are lying in, because this is where the everyday quietly hides the mathematics from you. The floor beneath you feels solid. The wall feels like a wall. The night outside your window feels like empty, restful stillness, a great calm nothing between you and the stars. But that calm is a kind of illusion your senses were built to sustain, so that you could get on with the small business of living. The truth running underneath is a structured and enormous thing. The galaxy you are turning with tonight does not float in emptiness at all. It sits cradled within a vast, roughly spherical cloud of dark matter, a halo far larger than the bright pinwheel of stars we call the Milky Way, stretching out and thinning gently over tens of thousands of light years, with the bulk of its substance gathered within a scale of some 21.5 kiloparsecs of the centre, and its full weight reckoned at roughly 1 trillion times the mass of our Sun. Almost none of that immense weight gives off any light. Most of the galaxy, by mass, is the part you can never see. The stars are only the foam on a far deeper sea. And when we try to rebuild the whole universe inside a computer, to grow it from that first faint smoothness forward through billions of years, and see whether we can make something that looks like the sky we actually have, we find we simply cannot do it with visible matter alone. Run the simulation with only the ordinary stuff, only the atoms and the light, and it gives you back a bland, thin, nearly featureless haze, a universe that never quite gathers itself into anything. But pour in the dark matter minus. Let it be the dominant weight, the first to clump, the scaffold that goes ahead in the dark minus, and the whole grand architecture appears. Long luminous filaments strung across the void like beads of water on a spider's thread, great sheets and walls of galaxies, and between them, hollow and immense and profoundly empty, the vast dark voids. The cosmic web, the largest pattern that exists, and it forms in every faithful reckoning we have ever run, only because most of what shapes it is something we have never once seen. And consider, if you will, what that quietly does to time, to the long, unhurried depth of it. Because the dark matter did not wait its turn. It did not arrive late, a guest walking into a house already built and lit. It came first. In the earliest ages of the cosmos, long before there was a single star anywhere to give the darkness a name, the ordinary mattersness, the hydrogen, the helium, the thin warm gas of the young universe naceness, was held back. It was jostled and buffeted and pushed apart by its own radiation, unable to gather, unable to fall inward and grow dense, because every time it tried to clump, the light streaming through it shoved it gently back out again. But the dark matter felt none of that. It could not feel light. And so, while the atoms were still waiting, still trapped in that endless standoff with their own glow, the dark matter was already sinking. Quietly, patiently, without a sound, it was pooling into the first faint hollows in the fabric of space, deepening them, drawing them down, digging the wells that everything else would one day fall into. By the time the ordinary gas was finally set free, the shape of things was already decided. The valleys were already carved. Every galaxy whose photograph you have ever seen, every spiral, every glittering cluster, every soft smudge of distant light grew by rolling down into a hollow that something invisible had hollowed out for it, ages before the first sun ever burned. The light did not lead. The light followed. What you can see was shaped entirely by what you cannot. And this perhaps is the strangest thing to hold in a quiet mind, that the visible universe is a kind of afterthought. Not the foundation, but the decoration upon it. Not the river, but the mist rising off a river you were never shown. Let yourself sit for a moment with how little we can actually say about the thing itself, because when you try to describe dark matter, when you try to state plainly what it is, you discover almost at once that you can only say what it is not. It does not shine. That is the first negation. It does not glow in any colour, at any wavelength your eye or any instrument ever built could catch. It does not absorb light, so it casts no shadow you could point to. It does not reflect light, so it throws back no gleam. It does not warm, it does not cool, it does not bond into atoms, it does not build molecules, it does not form dust, or stone, or water, or anything you have ever run your hand across. It does not collide with itself in any way we have managed to measure. It slips through the ordinary world, and through you, without so much as a whisper. And you can go on like this for a long while, stacking one refusal upon another, one absence upon the last, until you begin to suspect that this is the whole of what we truly know. Not a portrait, but a long list of the things it declines to do. We named it for the one property it seems unable to shed, its weight, its gravity, its stubborn insistence on pulling minus, and everything else about it is a door we have knocked on and found closed, and the mathematics only widens the room behind that door. When physicists gathered in the year 2025 to take stock of every search underway, every experiment, every telescope, every buried detector hunting for this thing, they found that the possible masses being looked for stretched across 90 orders of magnitude. 90. That is a 1 followed by 90 zeros, a span so wide the human mind has no honest picture for it. At the one far edge sit candidates, so unimaginably light they would drift through matter like fog through an open window, ghosts among ghosts. At the other edge sit candidates so heavy that a single one of them might be a black hole, born in the first second of the universe, wandering the dark between the stars. and we cannot yet say which end of that impossible ruler holds the answer, or whether the answer lies somewhere in the vast unmarked middle. Everyday experience gives you no help here at all. Your senses, your instincts, the whole comfortable arithmetic of a life lived among solid objects, none of it reaches into a question this size. This is the part the ordinary world keeps hidden from you. Beneath the reassuring weight of the mattress, beneath the plain fact of a floor that holds and a wall that stops your hand, there runs a question with 90 zeros in it, and no one alive knows the answer. And yet, and this is the gentle turn, the settling after the climb, this immensity is not a storm somewhere far away. It is here. It is around you. You are, at this very moment, sitting inside it. Our whole galaxy floats within an enormous, roughly spherical cloud of the stuff, a halo that dwarfs the bright spiral we live in, reaching out across scales measured in tens of thousands of light years. A characteristic radius of something near 21.5 kiloparsecs, and a total weight, out to its farthest reaches, of a little more than 1 trillion times the mass of our Sun. That is the true body of the Milky Way. The stars are only the glowing seed at its heart. And where you are, out here in the quiet suburbs of that galaxy, the dark matter is not dense. It is thin, almost tender in its thinness, roughly 1/3 of a single unit of energy mass in every cubic centimetre of the space around you, a presence so faint that if you gathered up all of it within the entire solar system, from the sun out past the last cold planet, it would weigh only about 100 million billion kilograms, which sounds vast until you set it beside the sky. It is the weight of one large asteroid, one single rock, taken apart and smeared invisibly across billions of kilometres of emptiness. That is how gently it lies upon us. So gently, in fact, that if the heavy end of that impossible ruler is right of niceness, if dark matter turns out to be those ancient black holes born before the stars, then by one careful reckoning, a single one of them would drift through the whole of our solar system only about once every 10 years. 10 years of waiting for one silent passage of one dark traveller through a space wider than you can hold in your thought. That is the texture of it, overwhelming in the total, and almost nothing in the particular. A universe built mostly of something, threaded through with a substance that outweighs everything you can see by roughly 6-1, and still, in the small warm room where you are lying now, it touches you so lightly that you have never once felt it pass. You do not need to keep all of this. That is the truth I want to leave beside you as the ideas grow larger and softer. You are not being tested. You need not hold the 90 zeros, nor the trillion suns, nor the asteroids smeared across the dark. Let them move through you the way the dark matter itself does, without resistance, without a sound, leaving you exactly as you were. There is one more layer beneath all of this, one last quiet room to step into, and we will go there slowly, together, with nothing at all required of you but to breathe and to stay where you are. So let us go down into it, this last room, the way you might go down into the cellar of a house you have lived in for many years. You know the house is real. You have slept in it and eaten in it and felt the floor hold steady beneath you 1,000 nights. And only now, quite late, do you go down at last to see the thing that all of that weight has been resting on the whole time. Everything we have followed tonight has told you one thing, and told it with a confidence that is almost unnerving. The dark matter is there. It bent the light around that ruined collision out in the constellation Carina. It held the outer stars of Andromeda to their impossible patient pace. It shaped the faint pressure of sound frozen into the oldest glow in the sky. Each of these is a different instrument, pointed at a different quarter of the universe, and each of them returns the same quiet verdict, without contradiction, without argument. And yet, for all of that agreement, not a single one of them has ever told you what it actually is. That is the strange shape of this final layer. Not the question of whether, which is by now as settled as anything in science ever gets. Not the question of how much, which we have measured to a sharpness that would have seemed like arrogance 100 years ago. But the plainest question of all, the one a child would ask first, and we still cannot answer. What is it? What is the substance itself, the stuff, the thing that all these long gravitational shadows are the shadows of? We have weighed it without ever touching it. We have mapped it without ever seeing it. We have given it a name, and the name is really only a confession, a pair of words that mean, when you turn them over, the matter we are unable to see. Beneath all the certainty there is a hollow, and in that hollow, quiet and patient, there sits a question the size of the whole sky. So the work of the last half-century has not been to prove that the dark matter exists. That case, as we have followed it tonight, was closed and closed again. The work has been to catch it, to find not the shadow, but the thing casting it. And here the story changes its character entirely. Up to now it has been a story of astronomers, of people looking outward and upward, at galaxies and clusters and the ancient light, but you cannot catch a particle by staring at a galaxy. To catch the thing itself, the searchers have had to stop looking up. They have had to go the other way. They have had to go down, into the deep rock beneath the surface of the earth, into the dark, and wait. But before we follow them down, we should meet the two great suspects, the two ideas of what the dark matter might turn out to be, and I want you to hold them lightly, the way you would hold two names you have only just been introduced to at the edge of sleep. You do not need to keep them. They will not be tested. The first suspect has a rather plain and clumsy name, and physicists, who are not always graceful, have called it the WIMP, the weakly interacting massive particle. The idea, first set out in a careful form by the physicist Gary Steigman and his colleagues in the late 1970s, is beautifully simple in its shape. Imagine a particle that carries real mass, somewhere between about 1 and 1,000 times the mass of a single proton minus so, heavy as the very small things of the world go. But imagine that this particle almost never touches anything. It ignores light completely, as we have said. And it ignores ordinary matter too, nearly all of the time, feeling only gravity and one other faint influence, the weak nuclear force, the same shy force that governs certain slow radioactive decays. A particle like that would drift through the whole Earth as though the Earth were a wisp of morning mist. Not stopped, not slowed, barely aware the planet was there at all. And what made the WIMP so beloved for so many years was not that anyone had seen one. No one had. It was that if such a particle had been made in the furnace of the early universe, the arithmetic worked out almost exactly right. The amount of it left over today came out close to the amount of dark matter we actually measure. That is the kind of coincidence that keeps physicists awake, a number that arrives on its own, uninvited, and fits. The second suspect could hardly be more different. Where the WIMP is heavy, This one is almost unimaginably light. It is called the axion, and it did not begin its life as an answer to the dark matter question at all. It arrived in 1977 from the minds of two physicists named Roberto Peccei and Helen Quinn, who were not thinking about galaxies or missing mass at the time. They were troubled by an entirely separate puzzle, a quiet inconsistency in the behavior of the strong nuclear force, the force that binds the hearts of atoms together. To smooth that inconsistency away, they proposed a new and very faint particle, and only afterwards did others notice that this particle, if it existed, would make an almost perfect ghost, a candidate for the dark matter that had been sought elsewhere. The axion, if it is real, would be extraordinarily small, not merely lighter than a proton, lighter than an electron, and not by a little, by a factor so large it strains the words we have, something on the order of 10 trillionths of the mass of an electron, a particle so slight that where the WIMP would pass through the earth like mist through a net, the axion would fill the room around you not as a scattering of grains, but as a kind of standing hum, an almost invisible fog of the very lightest thing. And it has one strange and hopeful habit. In the presence of a strong enough magnetic field, an axion may, very rarely, quietly turn itself into a particle of light, a single photon, whispering into existence where before there was nothing to see. It is by listening for that faint whisper that the searchers hope to catch it. So there they are, the heavy ghost and the light one, the WIMP that drifts through solid rock and the axion that hums through the magnet. Two candidates, wildly far apart in almost every property, and the honest truth is that we do not know if it is either of them. It might be one, it might be the other, it might be both, mingled. It might be something no one has yet thought to name. And this is the first note of the strange feeling that will grow over the rest of this room, that after everything, after all the certainty of the weighing and the mapping, when it comes to the substance itself, we are still, in a sense, guessing among strangers. But we are not guessing idly. We are guessing with instruments. And to understand what has been built to catch the WIMP, you must picture where it has been built, because the where is half the wonder of it. Nearly a mile beneath the town of Lead, in the hills of South Dakota, there is an old gold mine. For more than a century, men went down into that rock to bring up metal. The mine is quiet now, in the ordinary sense. But at the bottom of it, in a chamber carved out of the deep stone, one of the most sensitive instruments ever made by human hands sits in the dark and waits. It is called Lux Zeppelin, and at its heart is a great tank filled with liquid xenon minus, a heavy, clear, cold liquid, chilled far below freezing, held perfectly still. The whole thing is buried under that mile of rock for one reason, and it is a reason worth pausing on. Up here, at the surface, the world is ceaselessly rained upon by particles from space. Cosmic rays, streaming down through the air, through the roof above you, through the pillow beneath your head, every second of every night. To an instrument trying to catch the faintest possible touch of a dark matter particle, that rain is a roar. It drowns everything. And so they go down beneath the mountain and let a mile of solid stones soak up the roar until only silence is left. They are not building a telescope to see farther. They are building a room of almost perfect quiet, so that if a single WIMP should ever drift in out of the halo of our galaxy, and once in a very great while brush against one atom of xenon and make it flinch, they would catch that one small flinch in the dark and know it for what it was. And so they waited. Not for a night or a season. They gathered their silence for 470 days of careful watching, from the spring of 2023 to the spring of 2025. The liquid xenon held still and cold under the mountain, every faint tremor recorded, every stray flicker accounted for and set aside. This is patience of a kind the ordinary world rarely asks for. More than a year of the most attentive listening our species can perform, aimed at the quietest possible signal from the most abundant substance in the universe, which we have never once held in our hands. And when at last, in the December of 2025, they opened the results and looked at what all that silence had gathered, what they found there is the thing I want to carry you towards slowly, gently, as the room grows darker still around us. And what they found after 417 days of holding their breath beneath the rock was nothing at all. No flinch. No small bright stutter in the cold. Not a single tremor in that patient pool of xenon that could not be traced back, in the end, to something perfectly ordinary as a stray neutron, a whisper of natural radioactivity, the faint and expected drizzle of particles that the mountain could never quite keep out. They had built the stillest, most sensitive listening chamber our species has ever made, sunk it nearly a mile into the earth in South Dakota, cooled it, shielded it, watched it for more than a year with unblinking attention, and the dark matter did not come. It did not knock. It passed through, if it passed at all, without leaving so much as a footprint they could swear to. Now you might think, drifting there in the dark, that this is a story of failure. It is worth pausing, gently, to see why it is not. Because a silence like that is itself a kind of answer. When the December of 2025 arrived, and the results were opened, what the experiment announced was not a discovery, but a boundary, the finest boundary ever drawn around this problem. They could now say with more confidence than anyone before them that whatever dark matter is, it is not a heavy particle bumping into ordinary atoms as often as we had hoped. If such a particle exists, and weighs more than about 5 times the mass of a single proton, then it must interact with ordinary stuff even more feebly than this, more rarely, more shyly, more invisibly, than the very best net we have yet been able to weave. That is what world-leading sensitivity means. Not that they caught it, that they proved, with exquisite care, just how far it still lies beyond our reach. And here is where the small dread begins to gather at the edge of the hope. For decades, the favourite suspect in this long investigation has been the one they were hunting under that mountain, the weakly interacting massive particle, the heavy, quiet cousin of ordinary matter that so many hoped would step forward and be counted. It was a beautiful idea. It fit so neatly with other puzzles in physics that people half expected it to appear the moment the detectors grew sensitive enough. But detector after detector has grown sensitive enough, and still it has not appeared. Each careful silence, each new record, each empty year of watching does not disprove the particle outright. It simply squeezes it, corners it, pushes it into an ever smaller room of possibility, until you begin to wonder, quietly, whether it was ever in the room at all. So the search widens. This is the part I find strangely comforting, lying here in the dark with you, and I want to offer it slowly. If the heavy particle will not come, perhaps dark matter is something else entirely, something we have already imagined, but never confirmed. There is another candidate, first dreamed up in 1977 by two physicists, Roberto Peccei and Helen Quinn, who were not even thinking about dark matter at the time. They were trying to solve a completely separate riddle about the behavior of the strong nuclear force, and out of their solution fell a new particle, almost as an afterthought, light beyond imagining, perhaps 10 trillionths the mass of a single electron, so faint it makes the electron itself look ponderous. This particle, later named the axion, would ignore ordinary matter almost completely, but it carries one delicate promise. In the presence of a strong enough magnetic field, it might, very occasionally, transform itself into a flicker of light. And so, elsewhere in different laboratories, other patient people are not listening for a collision at all. They are sitting inside powerful magnetic fields, waiting for the dark to turn, ever so briefly, into a single photon. Consider how wide the search has become. At a great gathering of physicists in 2025, the candidates for what dark matter might be were laid out across a span of possible masses so vast it is almost difficult to hold in the mind 90 orders of magnitude, stretching from those feather-light axion-like particles at one extreme all the way up to primordial black holes at the other. 90 orders of magnitude. That is a range so enormous that if you started with something as light as the axion and multiplied it by 10, and then by 10 again and kept going, you would have to do it 90 times over before you reached the heaviest guesses. This is not the map of a mystery nearly solved. This is the map of a mystery in which we are honestly, humbly, almost completely unsure. And at the far, heavy end of that map sit the primordial black holes that may have formed in the very first second after the beginning, before a single star had ever shone, some of them so rare and so scattered that by one estimate one might drift silently through our entire solar system only once in every 10 years. So the net is empty, and the field of suspects has grown, if anything, larger. And yet, here is the tiny, stubborn thread of hope, and I will hand it to you as softly as I can. We are not standing still. On the 23rd of June, in 2025, high on a mountain called Cerro Pachon in the Chilean Andes, a new observatory opened its eye for the first time and released its first images to the world. It carries the largest digital camera ever built for astronomy, a camera of some 3,200 million pixels, mounted behind a mirror more than 8 meters across. And it is named, this feels like the universe folding a story neatly back on itself, the Vera Rubin Observatory, after the very woman who first watched Andromeda turn too fast and understood what that meant. This new eye will not try to catch a single particle flinching in the dark. It will do something else entirely. Over 10 long years, it will map the sky again and again, watching how the light of distant galaxies is bent and arranged and gently distorted, reading the shadow of dark matter, not by touching it, but by tracing its handwriting across the whole southern heavens. And so we arrive, you and I, at a strange and quiet ledge. After nearly a century of looking, from Kelvin's first uneasy arithmetic, through Zwicky's 400-fold discrepancy, through Rubin's flat and stubborn curves, through the clean cosmic proof written in a collision 3 billion light-years away, we can now say, with more certainty than we can claim for almost anything else in nature, that it is there, that it surrounds us, that it holds the galaxies together and shapes the whole vast web of creation. And in the very same breath, after all of that, we still cannot say what it is. And there is a temptation, lying here in the dark with that sentence hanging in the air, to feel it as a kind of failure. A century of the finest minds, of telescopes hauled up cold mountains and cameras the size of small cars, of detectors buried a mile beneath the black hills of South Dakota, waiting in the perfect silence for a single flinch that is not come. And at the end of all of it, this. We can weigh the thing. We can map it. We can watch it bend the light of galaxies and hold the cosmic web together across distances the mind cannot hold. And still we cannot name it. But I would ask you, gently, before you let that settle into something heavy, to turn it over once more. Because it is not a failure at all. It is one of the most honest sentences that science has ever been brave enough to say out loud. Consider what it would have been so easy to do instead. It would have been easy, at any point along this long road, to simply declare the mystery solved and move on. To say the missing mass was surely just faint stars, or cold gas, or some ordinary thing we had merely failed to see. And for a while, people did hope exactly that, but the evidence would not allow it. The collision 3 billion light-years away separated the light from the gravity too cleanly. The faint glow left over from the birth of everything carried the wrong pattern in its notes for ordinary matter to explain. And so, one comfortable answer after another was set gently aside, not because anyone wished to prolong the mystery, but because the universe kept declining to fit. What you are left with is not confusion. It is a mystery that has been sharpened again and again until only the genuine part remains. So let us sit with the not knowing for a moment, you and I, without any hurry to escape it. Because the not knowing has a shape. It is not a blank. When we say we do not know what dark matter is, we do not mean we have no ideas. We mean we have too many, and the universe has not yet told us which one it prefers. Perhaps it is the particle they call the WIMP, the weakly interacting massive one, a heavy and reluctant thing somewhere between the weight of 1 proton and 1,000 of them, drifting through you at this instant without so much as a whisper, betraying itself perhaps once in a great age with a single soft collision that our buried detectors have been holding their breath to catch. Or perhaps it is nothing so heavy at all. Perhaps it is the axion, a particle so faint and so light that it would take something like 10 trillion of them to match the mass of a single electron. A ghost proposed not to solve this mystery, but to mend a small and unrelated wrinkle in the theory of the strong force, which might, if we are lucky, turn a whisper of itself into a flicker of light when it drifts through a strong enough magnetic field. Or perhaps, and this is the strangest thought of all, it is not a new particle at all, but an old and terrible one worn smooth by time. Perhaps it is a vast population of small black holes, formed in the first single second after the beginning, before there were any stars to make them. Black holes born not from the death of anything, but from the sheer unevenness of the infant cosmos, drifting now through the dark, one of them passing perhaps through this entire solar system only once in 10 long years. And perhaps it is none of these. Perhaps it is something that no one lying awake tonight has yet imagined, something that will make all of our current guesses look, to some later listener, the way the ancient guesses look to us now. When the scientists gathered at their great conference last year to lay out everything the thing might be, the possibilities they had to keep on the table stretched across some 90 orders of magnitude of mass. 90. let that number rest against you slowly. It means that the lightest candidate we take seriously and the heaviest one we take seriously are separated by a factor so enormous that written out in full it would run to 90 zeros. That is not the width of our knowledge. That is the width of our honest ignorance, and there is a strange dignity in a science willing to state the size of its own not knowing so precisely. You might expect that gap to feel frightening, lying here in the dark, and yet I do not think it need be. Because notice what is not uncertain. The gap is entirely about what dark matter is made of. It is not, any longer, about whether it is there. That part is settled. That part is as firm as almost anything we know. The galaxy wheeling above wherever you are lying tonight is being held in its slow rotation this very second by a scaffolding of the stuff, a great invisible halo cradling every visible star, including the small ordinary one we happen to circle. You do not have to know what a thing is made of to know that it is holding you. A child asleep in a house does not need to understand the timber and the stone to be kept safe and dry by the roof. And so it is with us and this quiet, nameless mass. We are held by something we cannot see and cannot name, and we have been held by it since long before the first person ever thought to wonder. There is a freedom hidden in that, if you are willing to receive it. So much of what keeps a mind awake at night is the demand that everything be resolved, accounted for, filed away and finished before we are allowed to rest. We carry the day's small unanswered questions into the dark and turn them over and over, as though sleep were a reward that could only be earned by first solving everything. But the universe itself does not work that way, and it is doing perfectly well. The largest structures in all of creation are being shaped, right now, by something science has honestly labelled unknown. The great filaments of galaxies, strung across hundreds of millions of light years, the vast dark voids between them, the whole delicate cosmic web that our simulations can only grow when we feed the invisible scaffolding in first, all of it is arranged by a hand we cannot yet see the shape of. And it is not chaos. It is order. It is deep, patient, lawful order, holding steady across the entire visible universe, while the beings inside one small galaxy have only begun to guess at its nature. If the cosmos can carry a mystery of that size so gracefully, so calmly, without any hurry to resolve it, then perhaps you are permitted tonight to carry your own small mysteries a little more lightly. You do not have to solve everything before you sleep. Some of the most important things holding you steady are things you will never fully name, and they hold you all the same. And here, I think, is where the whole long story quietly turns and hands something back to you. Because you are not only a bystander to this mystery, watching it from a safe distance, the way you might watch a documentary and then switch off the lamp. You are inside it. You are made of the rare and luminous minority, the less than 5 parts in 100 of the whole that knows how to shine, the ordinary matter that learned, against extraordinary odds, to gather itself into stars and worlds, and eventually into a warm and thinking body lying in a dark room. But that body is not sealed away from the rest. The dark matter does not stop at your skin. It is streaming through the room and through the mattress and through the very cells of you as you breathe, roughly 1/3 of a unit of it, in the strange bookkeeping of the physicists, threaded through every cubic centimetre of the space your sun moves through. It passes through your chest as your chest rises and falls. It has been passing through every human who has ever lain down to sleep, through every night that was ever counted, entirely unfelt, entirely unnamed, until the last 100 years. So consider what has actually happened here, across the length of a single human century. The dark matter did not change. It has been exactly this abundant, exactly this silent, exactly this indifferent to light, since long before there was an earth to stand on. What changed is that a particular kind of ordinary matter, arranged into the pattern we call a person, slowly worked out that the dark matter was there. A Swiss astronomer with a difficult temper did the arithmetic on a cluster of galaxies and found 400 times too little light. A quiet, determined woman at a cold telescope in Arizona traced the same impossible speeds in the arms of a neighboring galaxy and would not let the numbers be waved away. And from those small, stubborn acts of attention, the less than 5% that can see began, at last, to take the measure of the vast and gentle dark that surrounds it. That is the thing I would like you to hold as you begin, now, to let go. Not the mystery as a weight, but the mystery as a companion. And there is an honesty in that companionship, because the plain truth, even now, is that we still do not know what the dark matter is. Perhaps it is the weakly interacting massive particle the theorists have chased for half a lifetime, a heavy and bashful thing somewhere between 1 and 1,000 times the mass of a proton, drifting through the deep xenon detectors a mile beneath the hills of South Dakota without ever once leaving a mark. Or perhaps it is the axion instead, a particle so impossibly faint that it might carry less than 10 trillionths the mass of a single electron, waiting, patient and unhurried, to be coaxed into one small flicker of light inside a very strong magnetic field. Or perhaps it is something stranger than either a primordial black hole born in the first second of time, one of which might pass through the whole width of our solar system only once in 10 years, or some form of matter drawn from a range of possibilities 90 orders of magnitude wide, most of which no one has yet had the imagination to name. The most sensitive instrument we have ever built has just finished 417 days of listening in the dark, and it heard nothing at all. And the hearing of nothing is not a defeat. It is the quiet sound of the question growing narrower and truer and closer to whatever is really there. So here is the small gift I would like to leave in your hands as your breathing slows and the room grows heavier around you. You are not required to solve this tonight. You are not required to solve it at all. The scientists a mile underground will keep their vigil whether or not you follow, and the telescope on the cold mountain in Chile will go on gathering the light of galaxies through the long southern nights without needing you to stay awake for it. Your only task in this hour is to rest inside a universe that turns out to be far larger and far kinder than the small lit portion we can see. Let the not knowing be a pillow and not a burden, and consider one last time the shape of the thing you are lying inside. Every galaxy you will ever be told about is a bright island of ordinary matter suspended in a vast invisible web, a scaffolding of dark matter woven through all of space, holding the shining things in place, cradling this galaxy, this sun, this world, this bed. It was here, exactly this abundant, and exactly this silent, before the first star drew breath. It will still be here, unchanged, long after the last of them has cooled. You are not a small creature marooned in an empty dark. You are held at this very moment inside an immense and gentle structure that asks nothing of you and lets nothing fall. That is not a reason for despair. That is a reason for a very deep and settled kind of wonder. To learn that most of the universe is unseen is not to learn that you are lost in it. It is to learn that the universe is more generous with its mysteries than you had any right to expect, that beneath the thin, bright skin of everything we can measure, there is a great steady abundance we are only beginning to feel the edges of. And the fact that a creature made of the visible 5% can lie in the dark and sense the other 95 is not a tragedy. It is, quietly, the most astonishing thing that has ever happened here. So let your eyes stay closed. Let the questions loosen their grip and drift off ahead of you, unanswered and unhurried, into the long night where they belong. The dark matter is passing through you as you fall, as it has passed through every sleeper who ever lived, carrying nothing away and asking nothing in return.